Hey, what's up? How's it going? It's Ham, and I'm back with another Unity tutorial, and this time we're going to continue where we left off with our audio sound effects. And so you can find everything that we've done so far on my GitHub repository. So just go, will be included in the link below. Go to the Super Mario Bros. World 1-1 in Unity repository, click on it, then just for the sake, at this moment, it should be merged with master, but we're going to click on a branch, and then you're going to select tutorial 15. Then from there, you can see, okay, at this moment, it's one branch ahead of master. We can do a pull request real quick. Initial sound effects. Yeah, that's fine. Create pull request, able to merge, confirm the merge. And all this is doing is making master now the equivalent of all the work up to tutorial 15, and this will change in the future. But for the sake of what I want you to do is ensure that you're on tutorial 15, because you can be watching this at a later moment where the repository's history is ahead or even behind if I go and change something and reset the whole entire thing. So yeah, make sure you are on branch tutorial 15, and from there you can choose to clone and download here. You can download a zip, you can copy it, copy URL, and then what we're going to do here is I'm going to use the GitHub GUI desktop app. You can also use the command line, but I prefer this just to make sure that, because there's other people on here, so I don't want to mess anything up. So obviously you can see I don't have a copy of this repository on my machine. So what I can do is I can clone again. For you, you won't see this. What you'll have to do is go to File, Clone Repository, and then paste in the URL that we just said, and then from there it'll create a local path. You can clone it that way and just press clone and it'll do it for you. And without further ado, I'm going to get Unity started up. So yeah, and it'll show you all the current branches. And you can say master all the way down to, well, we can't specify which one of these is which because the text is so long. But we can just kind of get a sense. 6 months ago, 10 months ago. Yeah, this tutorial has been going on for way too long, and I'm a terrible person for this. Okay, we're good. Everything's recording. So, okay, we're just gonna open this up. What we're gonna do is you're gonna go to your scenes in your assets folder, go to your scene subfolder, click on that. What we're going to do is select 2D. We're going to mute audio for now. I've kind of had a change of heart with the way that I want to go about doing the audio. So what I think that I'm going to do is remove this audio source from the player. Yes, you heard correctly. Remove the audio source from the player, and that now makes this player controller obsolete. Player controller script obsolete. What we're going to do now is go to our sound manager. Oh, wait. Control Z. We don't want to remove that just yet. Control Z. We want to copy the component because it has values that we've edited accordingly. So what we're going to do here is in our sound manager, we're going to make two child empty game objects for this. So we're going to make an empty game object and call it level music. Okay, reset the transform. It's already reset it. Drag this under sound manager. And okay, we can't do that. What I'm going to do is just copy this, Control D, call this sound FX. sound FX, and then we're just going to add a audio source component to both of these. And in this little, in our audio source component tab, we're just going to go to the little scroll setting wheel and go to paste values. And then, yeah, there we go. And then here what we're going to do is add an audio source component, and then we're going to go to our sound manager and we're going to copy component, remove component from there. Then we're going to paste the values as well as rename this and then save it. Sound FX. Again, press enter, so make sure you can save. Yeah, that sounds good. That seems good. That seems good. Really good. Okay. From there, we're going to delete this, remove the component from our player. Open up our player. No. A better way to do this is to go to our sound effects, our new sound effects, and then we're going to call this sound FX, lowercase x, manager, or script, or whatever you want to call it. So basically the idea of this is that I want to be able to, because okay, we're gonna run, if we continue, let me back up. If we continue down this track of programming all the sound effects through the player controller script, then we're gonna run the risk of having parts of the script that aren't coherent to other parts of the player controller class, things that have to talk back to each other with other scripts and other game objects, and it's just gonna be a really dirty, sloppy experience. No, I don't want to give feedback, Visual Studios. So what I'm going to do here is just make it to where the sound FX manager is able to easily take in. So, okay, let me just put it this way. One, we don't need any of that. What we're going to do is easily take in a sound clip provided by any of the game objects, any of the prefabs, any of the players, any of the enemies, and then play it accordingly. That's all I want to do, other than adding audio sources and specified scripts to where if something goes wrong in the sound, I won't be able to find it. I have like a pinpointed instance of where the sound is coming from and going to. So that's why I want to do it this way. So what I'm going to do is make a public void and call this play sound FX, and then we're just gonna make an audio clip, call it SFX, and then from here we're gonna say, okay, actually we do need the start. What we're gonna do is go to require component, say audio source, the audio source. Type of, there we go. I don't know how that wording goes. We just want to make sure that an audio source is attached. So what we're going to do is just say here, audio source SFX, lowercase SFX player. The X should be lowercase too. Oh, that's just weird. SFX, okay. SFX player, and then in the start, we're gonna set it equal to just void start SFX player equals game object dot get component, not ponents, audio source. The private can stay, make sure the line spacing is nice. So what we're gonna do here is just say SFX player dot play one shot of the SFX clip being passed in, and then yeah, this require not so much of a big thing. It's not gonna work if we don't have it. So yeah, literally these 2 lines of code will save us so much headache in the future. So just to give this a test, I'm gonna open up our assets, go to our scripts here, then I'm gonna say, go to our player controller, if I can find it, go to our player controller, then I'm gonna say sound dot SFX. So we need to add a sound manager. So serialized field sound FX manager SFX. So yeah, that's what we're gonna do. Just serialize the field, call it SFX, and then SFX effect. We don't need that. So audio source. Yeah. Well, honestly, you could just serialize the field for the audio source and have it on any game object and drag it on there. But that's I want to make things. I want to be able to tweak things if I need to go a step past that in the future. I want to be able to have that functionality. So what I'm going to do now is go to everywhere where it says SFX and just say SFX.play sound effect, and then we're going to pass in default jump sound effect. And then get rid of this, and then copy up, back. So we're just going to copy this line and change this from default to big jump. What I'm going to do is say no, let's not. So we're going to say SFX dot play sound effects coin sound effect. And let's try and see. This is going to be a little annoying. Yeah, we have unreferenced variables, and also we need to go back to our Visual Studios. We're going to open up our level time script and get rid of line 20 where it says print level time. Just get rid of that. That way we can actually see other important debug messages. And from here, what I'm going to do is go to our player script and then SFX. Grab the SFX script, just drag and drop the sound effects objects to the SFX, and it should grab the script that we need. So unmute this audio. Okay, yeah. Things work accordingly. Things work how we want it, and our player script looks so nice and neat, and that's exactly the way it should be. So what we're going to do now is we're going to do two things. So we're going to add the audio components to our brick blocks and our power blocks, as well as fix the classes that are associated with them, because by golly, they are atrocious. So we're going to go to our brick block script and we're going to open this up, and one of the most notable things that we're going to do is we're going to change all of these variables from public to serialized fields, simply because they don't need to be public. We just want to see them inside the inspector. So just copy and paste that all the way up. I got rid of the variable type. So game object, and then here what I'm going to do is I am going to make one public variable, public boolean of type bool, and gonna say is block full, and we're gonna automatically assume that the case is true. Or we honestly don't have to automatically assume. We can do that in our start, and what we're gonna do here is we're gonna say void start, create the proper spacing, go here, say if coin count is less than or equal to 0, then is block full equals false. We can by default set this to true. Okay, we're gonna set that to true by default. And if not, and also we need two more variables. We need a box collider 2D variable. We're gonna call this block, and then also it would be nice to have we're gonna detect where the brick block is being hit and deliver the award accordingly based on the bounds of the collider. So we're gonna say bounds and create a variable called hit zone. Totally up to you on what you name these. So what we're going to do first is say that block equals the usual. We're going to access the box collider 2D component, and yeah, then from there we're going to say that the hit zone is thus, sorry about that, the hit zone is equal to the block's bounds. And just to give you all a visual representation of this magic that's going on, we're going to go down here below our core routine, our IEnumerator of our trigger enter event, and still within inside the class we're going to go here and say void on draw gizmo. And let me just give you an example. So what we're gonna say is debug dot draw, or screw that. We're gonna say draw on gizmo, or no, gizmo, sorry, gizmo dot draw cube. And we're gonna start from, we want the center of this to be the bottom of the cube, or the bottom of our power block or our brick block, the bottom of our block directly underneath our block, I should say. So new vector 3, you're gonna say this can be 0, and then we could say bounds, or no, hit zone dot min dot y, and then our size we'll do vector 3.1. So we're saying that the center of this would be in the x coordinate 0, and then in the y it's gonna position from the bottom. So this should be half of this cube will be going towards the center and half of it will be extruding from the bottom, if we coded this correctly. The color of this is gray, which is not what I want it to be, but that's okay. See, as you can see here, half of it's going towards the center and half of it's extruding from the bottom. And you can get a better feel for that if we say gizmos.color equals color dot something like, I don't know, something really noisy, a color that has a lot of noise. So we can say vector 3.1 over 2. That's gonna subtract it or divide it by 2 in every axis. So x, y, and z. You can see it literally draws a cube inside of our cube and still has the same thing. So you can show this is kind of the area or zone that we want to have something in, and we can manipulate this accordingly, but which won't be necessary, I should say, because based on what we want, we want things to, let's see how I'm looking on time. Okay, 10 minutes left. Awesome. We want things to be able to, if the player hits the bottom, then we're good. Okay. And we want to yield a coin then. So these conditionals within inside the coroutine determine everything. And first things first that we need to do is in this last conditional, if coin count equals 0, we want to 1 play the famous bump sound, the famous bump, you know, when Mario collides with something that's empty or they cannot break, it bumps. It makes this bump sound. So play the famous bump sound effect, and then also you want to ensure that the block full status is correct. So we want to ensure that it's empty. So we're going to say is block full definitely for sure equals false. If the count of coins, ouch, I hit my funny bone. Oh, not so funny. So if the coin count is 0, equal, less than, or equal to 0, then yeah, we're broke and we aren't getting any more coins. So you're breaking me. So, and we can determine from there, we can go in the future, determine if it's destroyed or not. If it's destroyed or not. And by that I mean if the block or not. Okay. So yeah, we're gonna want to insert some more serialized fields for audio clips, but that's not what I want to do first. What I want to do first is continue along this path of ensuring that the block has been hit in the right area to yield the coins that we want. So first we're going to change this coroutine from an on trigger enter to a on collision enter. So we're going to say collision 2D and have the parameter called other, and then get rid of this. I'm going to say on collision, make sure I spell this and that you spell this correctly or it will not work. And if it yields the color that you see here, this beautiful color, then we know that it works. Or you could just type it in IntelliSense or a mono behavior, or what is mono developed? I don't know the IDE that comes with Unity vanilla or Unity by itself. I'm not sure, but yeah, hopefully you have this typed right or it will not work. So what we're going to do is we want to register the point of contact that a incoming collider makes with the brick, or the game object associated with this brick block class. And from there, we want to store that into a vector or a position. So how we do that is vector 3s, and we're just going to call it impact point. And then we can go here and further specify and say impact point equals other dot contacts. We're going to say the first contacts, because contacts are a series of arrays of information that are yielded or are filled based on collisions made with other colliders. And then we're just going to say contacts at index 0, which is the first contact, at point. And then, yeah, that's all we need to do. And then what we're going to do here is make a boolean. We're going to call this underneath, below brick, something like that. Something, you know, is below brick. That's nice. I like the is in my booleans. I don't know why. It just makes more grammatical sense. Okay, is below brick, and based on that, we're gonna say if the impact point at y is less than or equal to the hit zone dot min at y. So there we have a lot going on, and I should further explain the concept of bounds. So okay, first let's back this up. So I'm just gonna start from the beginning with our vector 3 impact point. So we're just creating a empty vector 3 to hold our contact point, and from there we're saying that based on the incoming collider, which I have specified already, that based on the incoming collider, which is our player, or say if something else hits it, but we don't know that that's like hypothetical, but based on the incoming collider, we're going to get the first contact point, and based on that, if the player has hit the block underneath, so if the first contact point is registered at a position underneath the minimum boundary, okay, I can't explain this without explaining boundaries. So this is the point where I will explain boundaries. So okay, up to this point, we have stored the exact position of the first collision between the two colliders, or where the two colliders make contact. That's the first position right here. And so from that, we're going to compare that position in the y-axis to the boundary in the minimum y-axis. And what that is, a boundary is basically, it is the area or the amount of, it could also be like the area, surface area, or just the world space that a collider fills. And based on that, we can do many different things to where, remember how back, if you follow the Koopa shell, so here, let me just open up the Koopa shell class. Here you can see that there is 3D and 2D collision, which is hella confusing. And that's because we're using a thing called raycast. And rays and raycast, to my ignorance earlier and throughout the development of this tutorial, they are very expensive and can only be used with 3D colliders. And if you haven't noticed, this is a 2D game. For the most part, this is a game made in the 2D perspective, I should say, because every game is essentially three-dimensional, because you have 3 axes to program and do stuff for. But back to my point. Okay, going back to the brick block script, and checking the time once again. Oh, we have 1 minute. Okay, so I'm gonna wrap this up. So okay, based on that, we're saying that, okay, the area that this collider fills, we want to go to the So in our X and Y plane, if you remember, so you have an X and Y plane. Let me just open up. It's okay if we go a little over. So in the X and Y plane, you have, okay, this is the Y plane of our blocks collider, and this is the X plane. So we're saying here in the minimum Y plane, which is basically at 0, if 0 equals Y, then that's going to be here where we were displaying the area of where our rendered cube is being displayed upon runtime. So basically, yeah, it is basically, imagine if we had a graph, a two-dimensional graph. We're back in college algebra. If you put in 0 for the value of Y, okay, Google, thank you so much for being efficient. Okay, if you put in 0 for the value of Y, that's essentially what we're doing here, what we did here when I was giving that demonstration. Because if you check here in our onDrawGizmo script, the draw cube takes in a vector 3, and I only pass in 2 parameters. So I pass in a 0 for my Y, a 0 for my X, and essentially a 0 for my Y. And that's all that the hitzone.min.y is, or dot whatever axis you specify. It's 0 in that axis. So I'm saying 0 in the y-axis. I could pass in 0 and still get the, what did I do? Still get the same effect that's being rendered on the screen. So I save my screen and save my scene, and then okay, no, again, sorry, I lied. we still need to specify what axis we're going in the minimum, because if you pass in 0, 0, then I think in terms of like boundaries, it registers the center. So yeah, that is why it's not the exact point, but okay, take my word off of that. Like, I'm learning with you guys still. It's taken me over 1.5 years to get to this point of like being able to explain this, and I'm still messing up, but I'm learning from my mistakes, which is a good thing. So we're gonna wrap up this video. So takeaway points. Okay, we changed our structure and flow of how we're registering, or how we're storing our audio clips, and then we're sending them off to be played. We don't want to send them to the player controller script, because literally the thing is that player controller script is only good for like collision stuff. So we're colliding with this block, yes, but this block is spawning a coin which can't play with, or can't collide with the player before it destroys itself, and it's not playing a sound. So it needs to play a sound before it destroys itself, so that we can get the effect, oh, I've scored a point. That's what the game wants you to think. And the way that we had it before in tutorial 15, being that this is tutorial 16, of sending everything to the player controller, having all the audio stuff there, is just very inefficient and nitpicky and kind of annoying. Granted, we could have done what I said of making a serialized field, adding an audio source, dragging it there and sending it and calling it a day, and just having all the game objects and stuff share it. But what if we want to add more functionality? What if we want to add, like, you know, different things, or like an array of audio sources, or you could just get all types of crazy. It makes like multiple sound effects play at once and all this. It's just so much you could do if you make that a class. And you're not limiting yourself, you're not bottlenecking for the future. Okay, that's why we did that with the audio. And back to this coroutine, we changed it from a on trigger enter 2D event to an on collision enter, because one, we don't want to add unnecessary trigger colliders and duplicate things in the scene and not fully understand what's colliding with what. We want our existing colliders to collide with each other, and then based on that impact point, or the point where they come in contact with each other, hence the contact points, we're going to store that into an empty vector3, which is going to be filled with the first contact point. And a contact is literally the point of contact between two colliders. And then based on that information, we're going to check to see if the contact point is below our brick. And if the player is coming from below our brick to hit our brick block the way that Mario would traditionally spawn a coin. And enough talking, let's try that out. So what we're gonna do is say if coin count is greater than or not equal to 0, that's a error if possible, like that's a hacky way to do things. We're gonna say is, and if the is below brick is true, then we're going to do this. And then what I want to do is I'm gonna debug.log two things. I'm going to debug.log the sweet spot, call this a sweet spot, and then colon tab here. So what is that? /t colon and then space and then plus impact point. Yeah, that's fine. So the point of impact. That's fine. So what this does is just formats the data, and then yeah, this gives me some information based on that. And then I'm going to change this wait for seconds from 2.5 to 3, just to get more of an idea of what's going on. So here, go here, so you can see in my console I have one sweet spot, and it's telling me the point of contact, which is underneath the brick block. And then I'm gonna hit it, nothing happens. Hit it, nothing happens. Or I hit it and it was under it, and you're breaking me. And yeah, so if I was to restart this, clear this out, or clear on play, that's a good point to make, and I hit it from here, or I hit it from the side, hit it perfectly from the side, nothing happens. Only if like the edge of my collider hits the bottom of the brick block, then something happens. But otherwise nothing will happen, and this is exactly what we want. But if you haven't noticed, the sound of the coin effect, or the sound of a coin being, you know, grabbed or taken, isn't happening. So what we want to do is add a serialized field and get that going. So we're going to add two serialized fields. We're going to call this an sound FX manager, and then SFX, then keep things going with serialized field audio clip coin SFX. So in our core team, we're just gonna say before the coin is destroyed, we're gonna say SFX dot play sound FFX, play sound FFX, and then coin sound effect. That's a tongue twister. And yeah, we're gonna save that, and then it's gonna display that information that we told it to, then destroy our coin, then subtract the number of coins and add to our score. And then from there, we're going to, I'm gonna exit out of this, go to our brick block game object, and then add the appropriate sounds. So sound effects, the only instance of that in our scene, you can just click here to these bulletin buttons and it will pull it up. And we're gonna be looking for, there's a nice search bar,
be looking for SNB underscore coin, and you could just type in coin in the search pane, and basically here. So if you listen closely, turn this up just a little bit. So coin, based on collision, it gives us the sound right before. So here, one coin, I'm hitting the block, nothing happens. The last coin comes only because I hit the bottom of it. And that's where we're going to end off for now. And our next goal will be making sure that this brick block script and this power block script, we're gonna just condense these all into one thing, and then make adjustments accordingly on base by base with like serialized information or even public information, and adjust the prefabs accordingly. So yeah, let's do that. So let's apply this to our prefab. So that's our brick block. Do the same with our player, and yeah, save your scene, save your project, save your code, and I will see you all in tutorial 17.
I just want to take a quick second to thank each and every single one of you. Thank you. Please do not hesitate to let me know if there's anything I can do to better accommodate these videos. Let's not be stereotypical programmers. I want to hear from you guys. Say hello to me on Snapchat, Twitter, Instagram. If you didn't like this video, leave a thumbs down, and that's totally cool with me. But if you liked this video, leave a thumbs up, and that's even better.